And we're back. It's time to sort it out with Mr. Sort Out. Here we have energy of displaced pendulum. So in the diagram we have the pendulum. We can measure the length of the string as it is just hanging straight down. Then we know the mass of the bob if we need it. We know little g where this is occurring as well. So go ahead and measure that length. Then when you click on this, it's going to displace it to an angle. It'll tell you what that angle is. And then our goal is to figure out the energy and then the speed as it's swinging at the very bottom. All right, so let's break this down a little bit. It really helps to draw a picture here where this is kind of the starting condition. Then this is once the bob has been displaced. So here, that length of the string is the same. Then we can think, okay, let's split this into two different sections. I'm going to call that H, and that would be kind of the distance from the point of attachment to where the bob is. It's that vertical distance. Then I can call this delta Y, and that is the change in height of the bob from when it is up here to then when it swings down to the lowest point. And as we know with energy, that change in height is everything. So do some trigonometry on that triangle, opposite or adjacent over hypotenuse. So cosine theta would be h over L, and then that means that h would be L cosine theta. Then, kind of compare these two. L is equal to h plus delta y. That means that delta y is L minus h. Then using energy, potential energy at the top would equal the kinetic energy at the bottom of the swing. So set those two equal to each other. And then remember we're using delta y, we're using this one that we found. And proceeding through that, we could find an expression for the final velocity. Okay, so that's how you do that one.